Work problems, the setup. Welcome to Mark's Math Methods. Example 1. Michelle, working alone, can mow a certain lawn in 5 hours. Victor can mow that same lawn in 7 hours when working alone. How long will it take to mow that lawn if they worked together? The key to work problems is how much work is done in one time period. Well, in this case, time period is hours. So we've got 5 hours and 7 hours. So Michelle and Victor, and then together. That's how we need to think about this. Michelle by herself takes 5 hours. So in 1 hour, she gets how much done? She gets 1/5 of the job done. Victor takes 7 hours. So how much does he get done in 1 hour? He gets 1/7. And then together, it takes X hours. We don't know what it is. So how much of the job can they do in 1 hour? They can do 1 over X. Okay, well, Michelle and Victor are going to work together. So we're going to add their contributions to get the total. So there's our equation. Now all you have to do is solve the rational equation, which hopefully you know how to do. The setup's the hard part. Example 2. Richard and Clara working together can trim a certain property's hedges in 3 hours. So together, 3 hours. Working alone, Richard takes twice as long as Clara. That's Clara. It's not as proficient at this. So how long would it take Clara by herself if she didn't have the slow Richard's help? Again, how much work is done in a single time period? 3 hours together. So if Richard takes R hours, we don't know what it is. We'll just call it R hours. How much does he get done in 1 hour? He gets 1 R. Clara, we don't know. We'll call it C hours. So in 1 hour, she gets 1/6 done. 1 over C. Together, it takes 3 hours. So in 1 hour, they're going to get 1/3 of the job done. Okay. Again, but it does say that working together, so we're going to add their contributions, right, to get the total. But we've got 2 different variables here. We can only need 1 variable. But we are told that Richard takes twice as long as Clara. So R equals 2C. So we're going to replace Richard's time, 1 over R, with 1 over 2C. And now we have our rational equation to solve. Example 3. A spigot can fill a certain empty tank in 4 hours. Drain B can empty that full tank in 6 hours. If drain B was accidentally left open when spigot A was turned on with the tank empty, how long before the tank overflows? Okay. So here's a picture, drain B and spigot A. A is putting it in, B is taking it out. So we've got spigot, drain, and together. We know that the spigot can fill the tank in 4 hours. So in 1 hour, it does 1/4. The drain can empty it in 6 hours. So in 1 hour, it can empty 1/6 of the tank. We don't know how long it's going to take before it overflows. We'll call it X hours. In other words, just before it fills, it starts overflowing. So that's 1 over X. Now, the two are working against each other. The spigot is filling, the drain is emptying. So we're going to subtract that to get our total. So 1/4 minus 1/6 equals 1 over X, where X is the time before it's full. We just have to solve this rational equation. I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.